news. It's great news. So I want to talk about tuberculosis. Okay, it is horrible. Okay, it's not a good thing. It's not a thing that helps humanity. Go into the future. Tuberculosis is a serious global health threat that affects more than 10 million people. You know what I mean? It knocks people out the box. Okay, it spreads through the air, and into the lungs, and the pathogen causes TB. Okay, which can lead to chronic cough, like chest pains, fatigue, like fever. It can kind of lead to weight loss, but not in a good way. So we're gonna talk about some actual good things that are coming from. You never would have guessed. AI. Man, they actually are doing good things with AI. Believe it or not. Surprisingly, not all of it is AI slop and videos and just getting people fired and losing billions of dollars. There's actually good things coming from large language models, from the ability of humans to gather all of our collective knowledge into a single point and apply it towards an objective. It's definitely a good thing. So, we're going to be talking about, okay, so AI-based technology accelerates discovery of new tuberculosis drugs. And wait, new tuberculosis. Ex- Okay, hold on. Not a good way to start off, right? Hold on, I need some water. I need some agua. All right. Luckily, I always keep water around. All right. I won't get tongue-tied. There's a good song called "Tongue Tied" by. Hold on. I gotta get distracted right quick. Hold on. Tongue Tied song. Who is it called? It's by Oh, so I forgot to push enter. That would have helped. There we go. Tongue Tied. Who is it by? Crap. Group Love. Yes. Look up the song "Tongue Tied" by Group Love. Great song. Just I recommend it. All right. To continue. So. Tuberculosis is very serious, as we said before. Now, while infections are more extensive in other parts of the world, a serious tuberculosis outbreak currently unfolding in Kansas had led to 2 deaths and has become one of the largest on record in the United States. Now, this article is from February 7th, 2025 by the newsmedical.net. So this isn't current. This is about a year ago. Like I said, lots of stuff happened that people weren't talking about, especially in regards to AI, which, is just completely negative right now. It's good to see some positive stuff about it. Now, while tuberculosis, oh, don't worry, I'll catch up. Give me a second. While tuberculosis is typically treated with antibiotics, the rise of drug-resistant strains has led to an urgent need for new drug candidates. Okay, because these viruses evolve just like humans, that they affect enough people, enough things, find them back, and then eventually they start to learn how to fight back and then adapt. Viruses are great. Okay, I mean, not really, but like viruses as an organism is fantastic. A new study published in Proceedings of National Academy of Sciences. Oh, God, don't you want to read that magazine forever? Oh, that'd be great. Describes the novel use of artificial intelligence to screen for antimicrobial compound candidates that could be developed into new tuberculosis drug treatments. The study was led by researchers at the University of California, San Diego, Linnaeus Bioscience Incorporated, and the Center of Global Infectious Disease Research at the Seattle Children's Research Institute. Linnaeus, I think that's Linnaeus, right? Oh, God, that's a great name. Linnaeus? Oh, where is King Linnaeus so I can worship him? Linnaeus Bioscience is a San Diego-based biotechnology company founded on technology developed in the UC San Diego School of Biological Science laboratories of Professor Joe Pogliano and Dean Kit Pogliano. Their bacterial cytological profiling (BCP) method provides a shortcut for understanding how antibiotics function by rapidly determining their underlying mechanisms. Now that was a great read. The search for new tuberculosis drugs I read that correctly. Laboratory methods has historically proven to be arduous and time-consuming, due in part to the difficulty of understanding how new drugs work against Mycobacterium tuberculosis, the bacterium that causes the disease itself. PNAS study describes the development of. I gotta stop moving so much. I think I'm rocking back and forth. Wait a minute. I just get so excited. You know, you guys, you'll notice like this is my natural voice. This is my natural voice. When I walk around, I talk like this. But when I get excited, my voice gets light like this. So you all, and then I start to move. So you always notice I get excited when my voice gets really light, and I start to move a lot. Otherwise, my voice is pretty just like it's like nails on a chalkboard. I can't stand my voice, to be brutally honest with you. But that's why I gotta read this more cheery. You know what I mean? Anyways. The new PNAS study describes the development of MycoBCP, a new generation technology developed with funding from the Gates Foundation. The new method adapts BCP with deep learning, a type of artificial intelligence that uses brain-like neural networks. I love the whole concept of neural networks. It needs to hurry up and get here, okay? The applications would be endless. To overcome traditional challenges and open new views of Mycobacterium tuberculosis cells. Oh, that's so awesome. Okay, so basically they're using AI to dive down into a cell, to basically get as deep into a cell as it possibly can that simply human eyes couldn't do with a microscope or with, you know, looking deep into, you know, what we used to traditionally do. Over 2 years in development, study lead authors Diana Quanch and Joseph Suji shaped the MycoBCP technology by training AI tools known as convolutional neural networks with more than 46,000 images of TB cells. Now a Linnaeus Bioscience, Quanch and Suji, both received their PhDs from the Chu Chin Ballet Development of Bioengineering and completed postdoctoral appointments in the Pogliano labs in the Department of Molecular Biology. Okay, so basically these guys, I mean, my goodness. Just to say what they do, you gotta rip your tongue out, you know, and step on it a few times. Like, my goodness, I'm gonna get better at reading. If you think about it, no one really like hardcore reads anymore. That's why this is also for me, because I consume videos now, you know, and then if I'm not consuming videos, everything's voice activated, everything's, you know, voice chat. I need to read again. Okay, so this is not only for you guys, but it's also for me, which is great. All right, so I'll get better as I go along, because I should not be getting tongue-tied with this. I read at a 12th grade level in 3rd grade. You know, I should be able to read. Anyways, back to the amazing discoveries of tuberculosis. Well, not the discoveries, but of what we can do about it. Tuberculosis cells are clumpy and seem to always stick close to each other, so defining cell boundaries didn't seem possible, said Suji, Chief Technology Officer at Linnaeus Bioscience. Instead, we jump straight into letting the computer analyze the patterns in the image for us. Like I said, now we can do so much more in a tiny space. You know, we can look at billions, trillions of spaces within a little tiny space, including a cell. Linnaeus teamed up with tuberculosis expert Tanya Parrish from Seattle Children's Research Institute to develop BCP for mycobacteria. The new system has already vastly accelerated the team's TB research capabilities and helped identify optimal candidate compounds for drug development. A critical component of progressing towards new drug candidates is defining how they work, which has been technically challenging and takes time, said Parrish, a co-author of the study. This technology expands and accelerates our ability to do this and allows us to prioritize which molecules to work on based on their mode of action. We were excited to collaborate with Linnaeus in their work to develop this technology to tuberculosis. To Mr. Tuberculosis? Is that what that is? Oh, Mr. Tuberculosis. UC San Diego Biotech spinoff tackles global health issue. Like I said, global. This dude. Curing diseases one step at a time is a sure step to human stability. Guys, we aren't having kids. There's a million reasons why, but we are on the steady decline as a human population of just not reaching replacement level. Okay, and like I said, you can say it's all kinds of different excuses, but the bottom line is that's the fact. So if we're not going to have new kids, okay, fine. We at least need to cure what we can as fast as we can to stop us from killing, you know, from dying, so that we can live as long as possible. Okay, tuberculosis, 10 million people a year. It's a big, Big deal. Imagine if it was gone. Imagine if it was gone. If it was as irrelevant as the chicken pox. You know what I mean? It was just something you didn't need to worry about. That's why this is important. That's why this is great, and no one talks about this stuff. No one talks about it. Like, this is great, fantastic stuff. Oh, I might take off my glasses now. I don't mind the light. Okay, so as we were talking about, this is awesome. Okay, especially because I know someone who had tuberculosis. That wasn't great. All right, anyways, we developed bacterial cytological profiling, and it allowed us to look at bacterial cells in a new way, said Joe Pagliano. It allowed us to really see how cells look after treatment with antibiotics so we could interpret their underlying mechanisms. We describe this method as equivalent to performing an autopsy on a bacterial cell. That is awesome. Like I said, we can dip into the cell far more than we ever could with AI. These are one of the benefits we need to be sharing. This is one of the great things we need to be posting about, putting research into, putting money into, dump it into this. We could have solved so much stuff. We could have a complete understanding of the cell, the human body, all this stuff yesterday probably, if we dump research into this and pay people to do this kind of stuff. Anyways, establishing Linnaeus Bioscience in the regional San Diego Biotechnology Hub allowed Joe and Kit Pagliano to rush the BCP technology out into the marketplace. Great! Now everybody can get it. Yes, share it with everybody. Where other companies could have access to it. The company now receives samples from all over the world for rapid analysis and identification of new bacterial drugs candidates. Okay, so lots of drug candidates coming out because now everybody has a piece of this, technology, and everybody can kind of submit their stuff as a peer review. But like I said, no matter if you're Chinese, if you're Iranian, if you're American, no matter if you hate each other, religious, blah, 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 who, what, why, where, everybody's gonna fucking die of tuberculosis. Okay, everybody's gonna kill by it. It's gonna kill everybody. It doesn't care what you are, where you are, when you are. It's going to kill you no matter what. So solving this is a good thing for people to do on a global scale, and it's something that, once again, we can work towards. If human beings can find things to work towards that affect all of us, you know what I mean, then generally we become used to working together, and then we can finally become a united human race. You know what I mean? When aliens come, it can't be black, white, Chinese fighting aliens. It needs to be the human race fighting aliens. Okay? Now I hope aliens come. I do. I hope they come, because 50% chance they'll be nice, 50% chance they'll be bad. I'll take it. Pagliano credits the biotechnology community, especially the company's early home in the San Diego J-Labs incubator, which supports early-stage biotech companies, as critical to the company's growth and success. We could not have gotten Linnaeus Bioscience off the ground if not for the supportive biotech community and the infrastructure provided by J-Labs, said Pagliano. All the company's employees at Linnaeus obtained their PhDs at UC San Diego, so this has become a great UC San Diego research, alumni, and San Diego biotech community success story. That is cool, man. Like, all you guys graduate and all you guys get to work together, like you guys built that badass science relationship together. You guys worked your way up, did your theses together and all that stuff, and then you get to work together. That's pretty cool. That's awesome. Everyone probably deserves to have that experience. Where was I? Aha! All the company's employees at Linnaeus obtain their... Oh, yeah, we already did that one. Okay, accumulating the AI platform. Wait. I got it. Once again, I get too distracted. So you can tell how light my voice is. Like I said, you can tell how excited I am. All right, let me focus. Okay, I'll start over. All the company's employees at Linnaeus obtained their PhDs at UC San Diego, so this has become a great UC San Diego research alumni, San Diego biotech company success story, culminating in this new AI platform to help solve the antibiotic resistant crisis. That's what we need, man. Viruses evolve just like us, okay? And if we're not gonna have babies, okay, fine, whatever. We can't force them to do it. Fine, whatever. I guess we'll fucking die off, whatever. But at least keep humans live long enough so we can get into space and then leave all the other humans to die over here, and then these people can start fresh. Oh, that's a whole nother conversation. No, whole nother story. But the only way that's gonna happen is if we live long enough to do it. Okay, and there's too many ways to die. There's too many ways to die. Disease, accidents, falling down the stairs, slip, slip in the tub. Oh God, Speaking of which, I almost just died right there. See how easy it is to die. Dying is easy. Okay, we need to make sure we have less ways that we can die. That way, we can go into the future as far as possible. Because the farther we get, the closer we'll get to that spaceship that takes us into space, and then we can actually become lost in deep space. But found in certain ways, you know what I mean? In addition to Quanch, Pagliano Suji, co-authors of the paper include Mark Sharp, Sarah Ahmed, Lauren Ames, Amelia Bagwat, Aditi Deshpande, and Tanya Parrish. Okay, and I'm gonna post all the pictures. I post pictures of everybody. Everybody deserves to get the credit. Hopefully they have pictures of themselves. But yes, this is a great article. This is awesome. Tuberculosis, like I said, it kills 10 million people a year. You know what I mean? And like I said, this is back from 2025. There's just so much potential in curing a disease with AI, because then AI will learn how to cure diseases. No, it'll be used to cure something, and then it'll learn, it'll learn everything, and then like, all right, maybe I can apply this to every other fucking disease. That'll make us live longer, okay? Once we live longer, we can work, work a little bit more so that we can build a spaceship. Get the fuck out of Dodge City. But that is a great article. Okay, I just wanted to point that out. No one is talking about the progress in tuberculosis treatments, and like I said, they made it. They added to a marketplace, so now all the world can kind of mess around with it, analyze the patterns and stuff, and be like, let's all link our stuff together. It's awesome. AI has some benefits. I want to talk about more positive things going on with AI. But yes, you guys have a great rest of the day, and bye bye. I now know how to turn off the recording. That button right there.